3.6 part 2, we are just going to put everything together that we did in the first lesson to graph rational functions. So we're just going to go through a few examples. The first one, we're going to graph 4x over x minus 1. Now what we want to start with are the x and y intercepts. So this is an idea from a while ago. To find x-intercepts, we set y equal to 0. So that would be setting this function equal to 0. So 0 equals 4x over x minus 1. So I can just multiply both sides by x minus 1. 0 times anything is 0, so that will just cancel out. So what that means is whenever I'm finding the x-intercepts of a rational function, that's just going to be setting the numerator equal to 0, right? Then divide both sides by 4, and we still get that x equals 0. All right, so to find that actual point on the graph, we would want to plug that in for x. Right? So if I plug 0 in for x, I would get 0 over 0 minus 1. So 0 over negative 1 would be 0. So that means the point 0, 0 is my x-intercept. So we can go ahead and plot that point. Now for the y-intercept, that means I'm plugging 0 in for x. So I would have 4 times 0 over 0 minus 1. And obviously in this case, we just did that for the x-intercept. So we would get 0 over negative 1, which is 0. So in this case, the x-intercept and the y-intercept are the exact same point, and there is only one of each. So we know the point 0, 0 is on the graph. Now we want to find asymptotes, like we did in yesterday's video. So vertical asymptotes, right? First thing we want to do is factor numerator and denominator and cancel out any common factors. There is no factoring to do here. So then we take every factor in the denominator and set that equal to 0. So if I set x minus 1 equal to 0 and add the 1 over, I will get x equals 1. So that means I have a vertical asymptote at 1. So let's sketch in a dotted line at x equals 1. All right? Generally, we use dotted lines for our asymptotes. Then, for horizontal asymptotes, we use our 3 rules that we talked about. In this case, the numerator and denominator have the same power. That means my horizontal asymptote is leading coefficient over leading coefficient. So y equals 4 over 1, or just y equals 4. So let's put in a dotted line at y equals 4. All right, so this gives me a lot of information about what my graph is going to look like, but I still need a little bit more. So what we can do now, we actually have a couple of options. We can either create a sign chart or just plot a few extra points. Personally, I'm a fan of the extra points method, right, where we just take a few more points and plug them in. So what we would want to do is think about where our vertical asymptotes are and plug points in on either side of those. Okay, so we already have 1 point on the left side of my one vertical asymptote, but let's get another point somewhere. So we know x equals 0. Let's plug in negative 1. So f of negative 1 would mean I'm plugging negative 1 in for x. So that'll be 4 times negative 1 over negative 1 minus 1, which would be negative 4 over negative 2, which would be 2. So that means the point negative 1, 2 is on my graph. Well, then let's plug in a point or two on the right side of my vertical asymptote. So my asymptote is at 1, let's plug in 2. So f of 2 is going to be 4 times 2 over 2 minus 1. So that'll be 8 over 1, which would just be 8. So the point 2, 8 is on my graph. Let's get one more. Let's plug in 3. So f of 3 will be 4 times 3 over 3 minus 1. So 12 over 2 would be 6. So the point 3, 6 is on my graph. And we can start to see what this is going to look like. Okay. Now, the big key with the asymptotes, right, is we want to follow our asymptotes. So once I have a couple of points, right, I know that my pieces of the graph are going to do this. This piece is just going to be contained by those asymptotes, as will this piece, right? It's just going to get closer and closer to those lines, but never cross them. Okay, so this is how we want to graph a rational function. Find the intercepts, find the asymptotes, and then just plug in a few extra points. All right. So here is a little cleaned up version of what that graph should look like, and we were pretty close. Let's do a few more examples. All right. In the next one, I've got x minus 1 over x squared minus x minus 2. So I'm going to start by factoring everything. That'll just make the rest of this easier. So this will be x minus 1 over, and we want two numbers that multiply to negative 2 that add to negative 1. I think that would be negative 2 and positive 1. So the denominator here would factor into x minus 2 and x plus 1. So there's nothing I can cancel. So now, to find x-intercepts, we want to set this equal to 0. And remember, we just said that was essentially setting the numerator equal to 0. So x minus 1 equals 0. Right? Add the 1 over, and we'll get x equals 1. So if I plug 1 back in, right, that tells me that the point 1, 0 is on the graph. All right, then y-intercepts, that's where x is equal to 0. So for a y-intercept, it's probably going to be easier to look at my original version, because if I plug 0 in for x, we'll have 0 minus 1 over 0 squared minus 0 minus 2. We can easily see that we're just going to have negative 1 over 2, or negative 1 over negative 2, which would be positive 1/2. So my y-intercept is at 1/2 right here. All right. Now let's look at asymptotes. Vertical asymptotes, we're not going to have any holes because no factors canceled, but I will have two vertical asymptotes because I'm going to set each factor in the denominator equal to 0. So we'll get x equals 2 and x equals negative 1. Okay, so let's draw in our dashed lines at 2 and at negative 1. Right? Now, horizontal asymptotes, the power in the numerator is less than the power in the denominator. That automatically means that my horizontal asymptote is y equals 0. So let's put that in here. Okay, so this graph is going to have 3 pieces. And now we talked about yesterday that it is possible for a graph to cross a horizontal asymptote. And since we already have a point on our horizontal asymptote, I know that this piece is going to cross. All right, so let's plug in a few more pieces here, a few more values. Let's start by plugging in a value to the left of this vertical asymptote. So let's plug in negative 2. So f of negative 2. All right, and it's probably going to be easier to plug into the factored form. Not necessarily, but I'm going to go ahead and do that. So we'll have negative 2 minus 1 over negative 2 minus 2 times negative 2 plus 1. So that will be negative 3 over negative 4 times negative 1. So that would be negative 3/4. So negative 2, negative 3/4 is going to be on the graph. Now, that essentially tells me that this piece is just going to be contained down here. All right, so let's move over here and choose a point to the right of this asymptote. So let's plug in 3. So f of 3 will be 3 minus 1 over 3 minus 2 times 3 plus 1. So that'll be 2 over 1 times 4. So 2 over 4 would be 1/2. So the point 3 1/2 is on my graph. Okay? So that tells me that this piece is going to be contained up here. Now, we're still not quite sure what's happening here in the middle. I just have these 2 points. So let's choose another point, and we're going to have to choose a half here. So let's go with 1.5 or 3/2. So if I plug in 3/2, okay, and you can use your calculator to do this step. You can plug 3/2 in. So I'll have 3/2 minus 1 over 3/2 minus 2 times 3/2 plus 1. So that's going to get me 1/2 over, that would be negative 1/2 times 5/2. So negative 5/4. So 1/2 times negative 4 over 5 is going to be negative 4 over 10, or negative 2 over 5. So that's going to be down here. Okay, so what ends up happening, right? We said that this piece is going to be contained in here. It's going to approach the asymptotes. This piece is going to be contained in here as it approaches the asymptotes. And then this piece is actually going to do something like this. Now, in this middle piece here, we do have to plug in values because it's not always going to look like this. Sometimes it may come down and then come back up, or it may, be contained down here. So we do have to plug in a few extra values if we ever have a middle piece like this to see what happens. Okay, so here is a little bit more cleaned up version of that. But again, we were pretty close with our sketch. Okay, let's do 2 more examples on the back here. First, x plus 5 over x squared plus 1. So x-intercepts, right? Setting the numerator equal to 0. So x plus 5 equals 0. Subtract the 5 over, and we'll get x equals negative 5. So that means this point is on the graph. Then y-intercept, right, is setting x equal to 0. So we'll have 0 plus 5 over 0 squared plus 1. So I just have 5 over 1, which would just be 5. So at 5 right here, I know that point is on the graph. Now, vertical asymptotes are where the denominator equals 0. Now, x squared plus 1 does not factor. This is a sum of squares. We can only factor a difference of squares. So if I think about setting this equal to 0, subtract the 1 over, take the square root, and I would actually get x equals plus or minus I. The square root of negative 1 is I. So what this means is we have no vertical asymptotes. There are no real values for which the denominator equals 0. Horizontal asymptotes then, well, the power in the numerator is less than the power in the denominator, that automatically means that y equals 0 is a horizontal asymptote. So let's put that in here. And we can actually see that we are going to cross that asymptote over here. So in this example, let's plug in a few extra points, right? This is kind of weird. We only have a horizontal asymptote, and I'm going to cross it at some point, right? So let's plug in a value over here. Let's plug in 1. So if I plug 1 in, I'll have 1 plus 5 over 1 squared is 1, so 1 plus 2, so 6 over 3. Or I'm sorry, that's 1 plus 1. I was jumping ahead. 6 over 2 is 3. So the point 1, 3 is on my graph. All right, this is kind of weird looking. So let's plug another one in. Let's plug in -1. So this would be -1 plus 5 over -1 squared would still be 1 plus 1. So that would be 4 over 2, which would be 2. So the point -1, 2 is on my graph. All right. So we can kind of start to see that this is going to do something like this, right? And it's actually going to come back down then and approach my asymptote. Over here, I'm going to cross the asymptote and then come back up. Okay, so this graph is kind of strange looking. Oops. Do something like that. All right. So it is possible to have no vertical asymptotes and end up with a graph like this. So again, a little bit more cleaned up version would be this, and it's difficult to tell, but this graph does cross at -5 and then comes and approaches the asymptote from below. Okay. One more example here. So in this one, again, if we can factor, let's do that right off the bat. So this is a difference of squares, so x plus 2 and x minus 2 over x minus 2. Okay, so x-intercepts then, right? We want to think about setting the numerator equal to 0, but we want to think about doing that right, after canceling anything out. So here, I would just be setting x plus 2 equal to 0, subtract the 2 over, and we'll get x equals -2. Y-intercepts, well, that's plugging 0 in for x, so that'll be 0 squared minus 4 over 0 minus 2, so -4 over -2 would just be +2. Now, vertical and horizontal asymptotes. Well, what happens right here, I was able to cancel out a factor of x minus 2. So we don't have any vertical asymptotes because I don't have any denominator left, but I will have a hole in this case. I will have a hole wherever that factor is. Okay, so at x minus 2, that would be, we want to think about setting that equal to 0. So if I set that factor equal to 0, I would get x equals +2. So we want to find out exactly where that hole is. So if I plug 2 into my function, and we can think about plugging that into this version. So all I would need to do is say, well, if I plug 2 in for x, I would have 2 plus 2. So I'm going to have a hole at the point 2, 4. I want to mark that on the graph that I have a hole there. Now, there is no horizontal asymptote here. Power in the numerator is greater than the power in the denominator. But now, to graph this, we can just look at my simplified version. This is just x plus 2. This is the line, the linear function, x plus 2. So this is a line with a slope of 1 and a y-intercept of 2. The only difference between this function, the function that I'm graphing, and the line x plus 2 is that I have a hole here at the point 2, 4. Otherwise, this is going to look exactly the same. So let me get a nice line going here. I've got a hole, so I'm jumping over that hole and then continuing like that. So here would be the graph of x squared minus 4 over x minus 2. We were able to cancel out a factor, so this ends up just being a linear function with a hole at 2. Okay? If we ever see something like this, where we can cancel out the factor and we just end up with a linear function, right? We don't really have to even talk about vertical and horizontal asymptotes. We know this is just going to be a line with a hole at whatever value would make the denominator equal to 0. Okay? So that is it for this video. The final question is going to pop up asking you what questions you have.